Every organization has assets so critical that a single unauthorized view or alteration could have lasting consequences. It's sensitive information and proprietary source code. These represent the intellectual core of the enterprise, the data that drives decisions, and the code that powers its systems and services. Annex 8.3 and A.4 of ISO/IEC 2701 recognize that these assets demand heightened attention and deliberate restriction. Improper access to confidential information or development repositories undermines both confidentiality and integrity, potentially exposing trade secrets, customer data, and operational mechanisms to competitors or adversaries. These controls provide the structured framework that ensures only those who truly need access receive it, and that every access action is traceable, justifiable, and revocable when no longer necessary. Annex A.8.3 focuses on information access restriction, setting the expectation that business and security information must be limited strictly according to classification, legal, and contractual requirements. The control spans all information types: internal documents, structured databases, unstructured data in collaboration platforms, and the applications that manage them. It integrates directly with the information classification policies established earlier in Annex A.15 and A.15, linking labeling and handling rules to real-world access enforcement. The overarching goal is proportional protection, ensuring that confidential data receives controls appropriate to its sensitivity while avoiding unnecessary barriers that impede legitimate work. Mechanisms for access restriction form the technical backbone of A.8.3. Access control lists, ACLs, define who can read, write, or execute specific files, while role-based access control, RBAC, simplifies management by assigning privileges according to job function. Encryption binds data confidentiality to user identity through key management systems, ensuring only authenticated users can decrypt protected information. Application and API access increasingly rely on token-based authentication, reducing password-related risks and enabling fine-grained revocation. For cases where users require partial visibility, such as analysts reviewing customer trends without viewing personal identifiers, data masking provides selective exposure. Each of these mechanisms enforces the principle of least privilege at a practical level. Operational discipline is equally essential. Before granting access to sensitive files or systems, pre-approval should be required, typically through a ticketing or identity governance workflow. Access rights must be revalidated through scheduled recertification cycles, confirming that users still need their entitlements. Any exception requests for urgent or temporary access should be logged, approved, and time-bound, ensuring no privilege persists indefinitely. Continuous monitoring tools can flag anomalies, such as mass data downloads or unusual access times, enabling security teams to investigate potential misuse. These practices turn access management into a living, adaptive process rather than a static configuration. The risks mitigated by A.8.3 span the entire confidentiality spectrum. Without restriction, sensitive business records such as contracts, strategic plans, or client details could be viewed by unauthorized staff. Excessive access rights often lead to unintentional leakage, where users copy data to personal drives or share it via insecure channels simply because they can. Insider misuse, a persistent concern in every industry, becomes easier to detect and deter when access controls are defined and logged. Finally, contractual and regulatory obligations demand demonstrable control over who can view specific data categories, particularly when handling personal, financial, or classified information. A.8.3 operationalizes these expectations into measurable safeguards. Evidence of compliance under A.8.3 should provide auditors with a transparent view of how access restriction functions in practice. Policies must align with the organization's data classification scheme, clearly defining access levels for public, internal, confidential, and restricted information. Logs should record each access request and approval, enabling traceability. Sampling reports from periodic entitlement reviews confirm that users' rights are regularly reviewed and adjusted. Exception registers, showing both approval and closure of temporary access, prove that exceptions are controlled rather than habitual. Together, this documentation demonstrates that restriction is not arbitrary but based on structured governance. Annex A.8.4 then narrows the focus to one of the most valuable and potentially fragile assets of all, source code. Code represents not only intellectual property, but also the foundation of an organization's operational integrity. Compromised code can lead to outages, embedded vulnerabilities, or deliberate backdoors that evade detection. A.8.4 recognizes both the commercial value and the operational risk of source code exposure. It applies to internal development, outsourced contractors, and shared supplier environments, encompassing source repositories, build servers, and automated pipelines. By securing these components, organizations protect both their innovations and their customers' trust. Threats to source code integrity take many forms. Insiders or external partners might exfiltrate intellectual property to competitors, while malicious contributors could insert hidden vulnerabilities or backdoors into production software. Weakly protected repositories, especially public cloud-based ones, are a frequent source of unintentional exposure when misconfigured. The growing use of open-source dependencies introduces additional risks, as private code may leak through poorly managed forks or unvetted third-party libraries. Each of these threats targets a slightly different weakness, but all share a common theme. Once source code escapes control, the consequences ripple far beyond technical recovery. Annex A, Annex 8.4, therefore extends A.8.3's philosophy of restriction into the realm of intellectual creation. Where A.8.3 governs data consumption, A.8.4 governs data creation, the process by which new systems and capabilities are born. Together, they reinforce the notion that protecting information means protecting both what an organization knows and how it builds. These dual safeguards ensure that business knowledge and technical innovation remain shielded from theft, misuse, or corruption, preserving the organization's ability to operate confidently in a digital landscape defined by constant exposure and relentless competition. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Annex A.8.4 focuses on the practical side of source code protection, the controls and behaviors that prevent misuse, corruption, or theft of a company's most valuable intellectual property. Source code is not just a technical asset, it is the living embodiment of how an organization operates, competes, and delivers value. Any compromise of that code, whether through unauthorized modification, exposure, or loss, can threaten customer trust, legal compliance, and long-term viability. The safeguards defined under A.8.4 ensure that every part of the software development lifecycle, from coding to deployment, operates within a secure, traceable, and accountable framework. Effective control begins with limiting access to repositories. Only developers with a legitimate need should have direct access to source systems, and their rights must correspond precisely to their assigned role. Multi-factor authentication is mandatory for all repository access, ensuring that credentials alone cannot open the door to manipulation or theft. Commit signing with cryptographic keys verifies the authenticity and integrity of every code contribution, preventing impersonation or tampering. Development and production environments must remain strictly segregated, eliminating the possibility that experimental or untested code contaminates operational systems. Continuous monitoring of commits and peer review cycles provides early detection of suspicious changes. These combined controls create a culture of integrity that underpins every successful development operation. Supplier and third-party relationships introduce another dimension of complexity to code protection. Many organizations rely on external contractors, offshore teams, or partner firms to support development or maintenance activities. Each external entity must operate under binding non-disclosure agreements, NDAs, and formal contractual clauses that specify source code protection obligations. When contracts conclude, secure code escrow arrangements or verified handovers prevent intellectual property loss. Geographic and jurisdictional factors should be considered carefully. Some organizations restrict offshore access to sensitive repositories entirely, or impose additional approval workflows for unvetted contributors. Reviewing and retaining third-party access logs ensures visibility beyond internal boundaries, confirming that external collaboration doesn't weaken overall control. Strong operational discipline is vital for internal development teams as well. Every change should undergo a formal pull request and peer review process before being merged into main branches. This not only improves code quality, but also introduces a layer of oversight that deters unauthorized alterations. Static analysis and security testing must occur automatically with each commit, identifying vulnerabilities or policy violations early in the pipeline. Sensitive modules, such as those involving authentication, encryption, or data handling, may require dual sign-off by senior developers or security engineers. Comprehensive version control and rollback capabilities ensure that if a malicious or faulty change is introduced, the system can be restored quickly and verifiably. Auditors assessing compliance with A.8.4 look for both procedural and technical evidence. Repository access logs must show that multi-factor authentication is consistently applied. Records of code reviews and sign-offs provide proof of human oversight, while automated testing reports validate that secure development practices are operational, not theoretical. Policy documents describing secure coding standards and development procedures demonstrate organizational intent, while third-party contracts confirm that suppliers are bound by equivalent controls. Collectively, this evidence shows that code integrity isn't assumed, it's continually verified. The cost of failing to implement these measures is steep, as illustrated by numerous real-world cases. Developer repositories exposed through simple misconfigurations have revealed entire product blueprints and encryption secrets to the public. Insiders with unchecked access have inserted unauthorized code into production environments, resulting in breaches that went undetected for months. Organizations that failed to manage supplier transitions have found their proprietary code repurposed or claimed by contractors after contract termination. Even regulatory bodies have intervened in cases where software handling sensitive data was compromised because of weak access controls. Each example underscores how the loss of code control translates directly into loss of trust, reputation, and competitive advantage. Different industries face unique stakes when it comes to source code protection. In financial technology, trading algorithms represent millions in intellectual value and must be segregated behind strict access controls. Healthcare software developers are subject to patient safety audits, requiring demonstrable assurance that medical systems are free from unauthorized code changes. Defense contractors must comply with classified repository requirements, often implementing air-gapped or cleared environments. Cloud and SaaS providers must maintain secure continuous integration and deployment (CI/CD) pipelines to prevent accidental exposure during automated builds. These examples show that while the principles of A.8.4 are universal, their application must align with each sector's operational realities and risk tolerance. When viewed together, A.8.3 and A.8.4 form a coherent defense strategy across two levels of information protection. A.8.3 governs the business and operational data that sustains an organization's daily decision-making, while A.8.4 governs the creative and technical assets that drive its innovation. Both rely on restricting access based on legitimate need, implementing layered authentication, and maintaining constant oversight. The difference lies in granularity. Data access focuses on consumption, while code access focuses on creation. Combined, these controls safeguard the entire knowledge ecosystem, protecting both what the organization knows and how it turns that knowledge into action. By enforcing these controls, organizations establish a demonstrable posture of security governance that resonates with regulators, customers, and investors alike. Access restriction for information in source code is not merely a compliance requirement. It is a declaration of discipline and respect for intellectual integrity. The ability to trace who touched what, when, and why builds trust internally and externally. It also aligns with modern zero-trust architectures, where verification replaces assumption at every layer of interaction. Through A.8.3 and A.8.4, the ISO 27001 framework reminds us that true protection is not about secrecy alone. It's about structured accountability that ensures every privileged action serves the mission, not the threat. When these two controls work in concert, they create a resilient barrier between sensitive knowledge and potential compromise. Business information remains available only to those authorized, and proprietary code remains authentic, uncompromised, and under verified stewardship. The organization not only protects its intellectual property, but also sustains confidence that its most critical assets, the ones that define its value and reputation, remain secure by design. In the digital economy, where information and software are the lifeblood of enterprise, that assurance is not just a technical achievement, but a strategic imperative.